Welcome back with another lecture about electron configuration. And I'm going to practice more example. And in this case, we're going to go after chlorine. Chlorine, it has 17 electrons. So the electron configuration for it is going to be 1s2, 2s2, 2p6. And then we get 3s2, and last orbital 3p5. So the p orbital is not full, partially occupied. So let's put the electron in it. I go up, 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 and then this one will be down, down, and one of the orbital is half occupied. Okay, now the highest n here, the highest n is going to be 3. Okay, this element belongs to the third period, so I'm going to say the third shell or third, like a layer. And now the third, if we look to the third shell, we have 2 orbitals in it. So valence electrons is going to be equal to the highest ns plus np. The highest ns plus np. Okay, I have 3s orbital with 2 electrons. Then I have a 3p orbital with 5 electrons. I'm going to add those electrons. So I go 2 plus 5. That's going to give me 7. So chlorine belong to the group 7 and the third period. Okay, and rest, we call them core electrons, and we have 10 of them. So chlorine is equal to, previous noble gas of chlorine is neon, so you say neon, and then you say 3s with 2 electrons and 3p with 5 electrons. And that's going to be the short electron configuration of chlorine. Okay, now what will happen if we want to take electron or give electron to chlorine? And this is the electron configuration of chlorine. So let's copy paste instead of this. Okay. We're going to go after 2 examples. The first example, we will give it electron. The second, we will try to take electron from the system. Okay. Okay. So I want to turn chlorine to chlorine -1. What does it mean? It means we added 1 electron to it. So you need to ask yourself, what's the first available orbital? Okay, and this is going to be equal to neon. We have a 3s with 2 electrons. 3s is full. So it's not going to accept any electron, but 3p says 3p5. That means we do have 1 orbital there, 1 half occupied orbital there. So we said we go up, 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 and then we say down, down. That's neutral chlorine. But because we added 1, so we're going to say we have 1 here. That means we have 6 of them. So I need to add 1 electron there. Okay, you will add the electron to the first half occupied or empty orbital. Okay, add it to the first available orbital, whether it's half occupied, partially occupied, or fully in empty, completely empty. Now, what if I want to take electron from it and I want to turn it to +1? Okay, in that case, you will take the electron from the last orbital. And what's the last orbital? And the last orbital is a 3p with 5 electrons. So you will take 1 electron from it, and that's going to turn to 4. So the electron configuration is going to be equal to neon. And then we will have 3s with 2 electrons, and the 3p will have 4 electrons. Okay, so the last orbital, you will have up, 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 and now we have only 4 electrons. So like the first one, it will be paired, and I will have 2 unpaired electrons. Okay. Now, next subject will be the transition metal. I want to talk about transition metal and what's the transition metal. If the last orbital that you're dealing with, whenever you're writing the electron configuration, is a d orbital, in that case, we're going to say you're dealing with transition and metal. So transition metal, it has d orbital that is getting full, trying to get full, or maybe is already full and is the last orbital. It's the last orbital that you put electron in it. And in that case, remember we said n-1 for d orbital. And let's give it a try. We have the iron 26, so it will be 1s2, 2s2, 2p6, and then 3s2, 3p6. Now we jump to 4s with 2 electrons. Until now, we have 20 electrons. Forgive me, this one is going to be 18 electrons, my bad. Plus 4s, it will be 20. And this is going to be equal to argon. Okay. 4s, if I add 4s, it will be 20. Okay, now I have a 3d orbital with 6 electrons, and the d orbital is not going to be full. We have 5 orbitals. Here you go, 5 orbitals. I'm going to put 1 electron inside each orbital. 5 of them, and this one is number 6. So I do have unpaired electron, so this element will be paramagnetic. Okay, now let's talk about the highest n. The highest n is going to be equal to the period. So this element belongs to the the fourth period. Okay, the fourth period. Now, when it comes to valence electrons equal to group, you will say this: the highest ns plus n minus 1 d orbital. So we used to say ns plus np. Now we say ns plus the d orbital. We have 4s with 2 electrons, and then we have the 3d with 6 electrons. We're going to add those electrons. So we say 2 plus 6. This element belongs to group 8, but I want to say this is different from noble gases, so I will put B in the front of it. That means transition metal. Okay, now let's show electron configuration of iron again. And so we have iron, first layer. We had only 1s with 2 electrons, and then n equal 2. We had the 2s2, 2p6, and n equal 3. We had the 3s2, 3p6. Now n equal 4. We had 4s with 2 electrons. The question is, where do you put the 3d orbital? 3d orbitals, you have to put them here. You have to put them there on the third layer, 3d6. Okay, now the question is, which one of this layer is you know away from the the center or the nucleus of the element? Okay, which one of them it has the longest distance from nucleus? It's going to be the fourth one. And remember this: force is equal to K multiply Q1 multiply Q2 divided by the square of distance. You can say the Q1 is the positive charge. It's inside the nucleus, and this one is going to be the negative, or the electron that we are talking about. As R goes up, force will go down. What does it mean? It means it will be easier to take electron from the last layer. So if I want to take electron from transition metal, okay, for example, I want to make this one +1, which is equal to argon 4s2. Then we say 3d6. Let's write this one as neutral first. Okay, that's iron. So I go 6 here. And then when you say iron +1, you're going to take electron from 4s orbital. So you say 2 minus 1. And then you keep the 3d as it is. So that's going to give you argon 4s1 and then 3d6. Okay, and if you want to turn it to iron +2, then you say argon 4s2 minus 2. Then you write the 3d6. So this one is going to give you argon 3d6. Now, what happened with the s orbital? The s orbital is completely gone. Okay, so you will take the electron from the last layer. Okay, from the last layer, because last layer is way from the nucleus, so it will feel less attraction force from the nucleus, and losing electron or taking an electron from that shell is going to be way, way easier than taking an electron from D or core electrons. Okay. Now, if I want to put electron, where do I put electron? Let's say this is iron, and I want to give it 1 electron. In that case, remember, you have argon 4s, 2s orbital is already full, but then you have the 3d with 6 electrons. So you're going to add electron to the first available orbital, and that's going to be this. Argon 4s2, and then we get 3d7 electron. So you will add the electron to the first available orbital. And I'm going to stop the lecture here, and thank you very much.